Dave, aka the Guru, and another tutorial on Gamesalad. This is part 2 of our tutorial on physics and the physics engine in Gamesalad. So we're going to start to look at some of the attributes in relationship to actors that we can modify that affects the physics and how actors relate to one another. So one of the first things we're going to do to make this easier is I'm going to go to the Home tab and then to the actors, and I'm going to go ahead and make a tag, and I'm going to call this tag Collide. And then what I'm going to do is I'm going to go ahead and drag the 3 actors that I'm going to use for this demonstration under that tag and designate them as such. And what that's going to do is allow me to basically address each one of those actors with a single collide behavior under a tag without having to make 3 individual separate using 3 individual separate collide behaviors. So let's go ahead. I've made this actor and I just called it the ground. Since we're going to be simulating gravity with an accelerate behavior down, and we want to make sure we have some kind of obstacle here that we're going to collide with. If not, our actors would just go right off the scene. So we need to establish a place where the actor can't move anymore in our physics world. So let's just go ahead and open this up, and you'll see I've got movable unchecked. I've left the density and the friction basically set at the defaults, and the collision shape set to rectangle. And this will basically, it won't move at all, and it'll give us a real sturdy mass. But we can still modify these 3 particular attributes here to affect how any particular actor interacts with that ground actor. So let's go ahead, and I'm just going to grab this platform actor here, and let's go ahead and open it up, and I'm just going to go ahead and unlock the prototype, just make it easier for me so I don't have to go back and forth. So let's keep this, and we can get rid of, see, usually if we didn't use tags, we would have to, because we want this to collide with the ground and I want it to collide with my player, so we would have to multiply this collide behavior a bunch of times. Now by tagging it, we can just say go ahead and collide with everything that we've got set up with under the collide tag, and that makes our code slimmer and much easier. So let's come over here, and we don't want to have any bounciness, because what I'm going to do is I'm going to push this object around with my actor. And I want you to be able to, we're going to go ahead and look at density and friction in this particular example right here. So I want to go ahead and check fixed rotation, because I don't want this thing like tipping around or anything. I want it to stay on a fixed angle. So I'm going to go ahead and select that, and then I'm going to go ahead and simulate some gravity. So I'm going to go ahead and grab the accelerate behavior, and I'm just going to simulate an acceleration down of 100, which will give me a constant force pushing down. I'm not going to put it in any rules. We want the direction to be down, so that would be 270. Excuse me, 270 in relationship to the scene, not the actor. So now this will give us a simulated gravity. This will collide with this actor and give us a tight fit here. So let's go ahead and we'll grab this player actor that I have, and we'll just narrow him down, make a little bit more like a player would. So we can go ahead and come in here, and I'm going to unlock this prototype as well. And I want him to be movable and fixed rotation, and I don't want to have any, we're not going to deal with bounciness right now. I like to go ahead and, even though I've kind of established some stuff, let's go ahead, I'm just going to add another tag here, because I need this actor to collide with, I need the player to recognize that he's colliding with the block as well, since I don't have a collide in there. You don't have to throw collides in everything. Pretty much if you cover your player, and that's what you're really concerned about with the collisions, other than the ground, you don't have to really worry too much about putting a collide behavior in your other actors. There's really no need for it once you've established a certain player that's going to be interacting in your environment, and unless you're stacking blocks or doing something, you basically only need the collide behavior. You don't have to throw it everywhere. You'll figure out when you're having collisions and when you need to add them into other actors. But this will pretty much, it keeps it pretty simple, and you don't have to have all this redundant code in your game. So let's go ahead and let's open this back up, and let's just go ahead and quickly make some, we want to make it move left and right pretty simply. So we'll just make a rule, and I'll use the keyboard commands, and I'll say when the right key is down, we're going to go ahead and we'll grab the move behavior, and we'll just do a simple general direction move. I want this to be stacked. I don't want it to be additive. In other words, I don't want my velocities to be adding on top of each other, since I'm going to have multiple move behaviors. You can have it as additive, and we'll get into that in a later tutorial. So I'm just going to go ahead and click stacked. And for my right, I do want it to move to the right of the scene, and I'll just keep my speed at 300. That's a pretty good speed. So I'm just going to go ahead and copy this rule, and I want to go left on this one, so let me just change the keyboard to left, and then I'm going to go ahead and it's going to be 180 is the opposite direction. And you can always kind of keep track of what that is by this little knob on the wheel that you can grab. Kind of gives you a visual representation of which direction you're really talking about if you get confused by those things as well. So now we've got the one last thing I do need to add is I need to add the accelerate behavior. So this actor is, and we're not going to put that in a rule. So we're going to want this at 270. And we want that related to the scene, and that's going to simulate gravity on our actor as well. So now let's just go ahead and look. So see, now we have our actor, and I'm moving him back and forth with the command. So let's just, excuse me, let's just take a look at density for a second. In impacting in actors. So let's say that I want this player actor to push around this block. So right now, if I come up to it, I can pretty much push the thing right off the scene. That's not going to work for us. So let's go back and let's go into our, we'll keep the player actor's density at 1, which is fine. And let's go ahead and just increase the density on this. Let's just add it to 50 for an example. And let's just go ahead in and knock it again. And so now you see that it takes a little bit more effort for my player to move the device. He can actually strike it a bunch of times to get it to move. And then if we went ahead and really pushed this up by like 100, we can make it even more difficult to kind of push this object along. As you can see, as the more I push it, the more velocity it gains, and it keeps moving. So now one of the things that we want to deal with, so now that we know that basically density impacts how the velocity of one actor, what it takes for an impact in velocity to make the actor move. So the higher you increase the density, the more velocity you need on your impact to move that actor around on the scene. So you kind of, those are numbers with the density you kind of adjust and play with till you get what you want. And so also what we'll do right now is we'll kind of create a little balance. And so we'll go in and mess with the friction. As we saw, that actor kind of keeps floating. But let's say that we wanted our actor to kind of move a little bit and then stop, kind of a more natural, since we're, let's say we're not simulating a slick surface, but it almost looks like it's on rollers. And we really want more of a natural sense when we're pushing something, it'll kind of move and stop. So let's go ahead and let's throw some drag on there. And let's try a drag of 50 and see what that works for us. And we'll go ahead and just push that actor. And as you can see, it becomes much harder to move that actor. Now that's not really what we want. So let's go ahead and let's dial that drag back to like 10. See what happens. See if we can find a happy medium here. And so now we're moving it, and then as we see, it's gonna slow down a little bit. So one of the things I think we'll do is let's dial down our density a little bit, and then let's see. We get a little more movement when we push it, so we get a little bit of more of a move, and then more of a floating. And so we could go ahead. Let's ratchet our drag up a little bit. And let's see how that, so we get a move, and then we get a little quicker stop. So as you can see, you really have to kind of play with these numbers a little bit and really have to kind of get the feel for what you're after in the physics engine, what you're trying to recreate. And you'll have to play with those numbers up and down when you're adding, friction against density and the velocity of your actor, what you want to accomplish. So it's not just setting the density and then setting the friction. You really want to play with those numbers up and down until you kind of find an equilibrium where you get the movement and the effect that you're looking for over time, because it's real physics. Now, one of the things I want to point out to you that I think a lot of people get hung up on is that in Gamesalad, when we have movable actors, we've all gotten into the habit, because when you have a movable actor and you have values assigned to these numbers, it kicks in the physics engine, and if you drop these to 0, it takes those values out of the physics engines and makes the calculations a little bit easier on the code. And so a lot of times we've gotten into the habit of going into these actors and setting all these values to 0. Now that's fine to do, and you can even have the 0 density in like your player actor. But when it comes to friction or even bounciness, you can have that kind of a one-way thing where you can have one actor at 0 and you can have another actor at bounciness goes anywhere from 0 to 2 and then decimal places in between. And so you could have one actor with a bounciness of, say, 1 and the other actor that's interacting with, as long as it's collidable, at 0, and you're still going to get bounciness. The same way with density. The problem with friction is, in the Box 2D engine, friction doesn't calculate that way. So in other words, friction will not calculate, because what happens is that how friction is applied in the physics engine is that it does a multiplication or an evaluation of multiplying the friction of one actor with another, and it combines them. So what happens is, if in one of those actors that you're interacting with has a value of 0, that becomes the default in the equation. So even if you had a friction set of, say, 500 in one actor and 0 in the other, the friction sum is going to be 0. So you're not going to have any friction. So if I took this actor here, let's say, and let's get rid of the drag, and then we'll do some friction here. So right now we have a friction of 3. So let's do a friction of 100, and let's go ahead and simulate that same kind of situation where, so see, now we're having that push, and then we're having a similar effect to like drag. We're actually creating some friction between the ground. So let's go ahead into the ground actor for a minute, and we're going to see that in my ground actor I have a positive value in friction. So let's look at what happens when I change that value to 0 and then try the same thing. So we're going to see that it's much easier for me to push. I don't have a friction value anymore. So if I go into my ground actor and I set the friction to a positive value, even like 1, I'm going to get that heavy friction back because it's giving me a positive value to multiply by. Unlike when I set it to 0, I wasn't getting any friction. So if I go back into my ground actor, and I find that 3 seems to be the default, and so I'm thinking that that's somewhere near the benchmark where you want to be. So I would leave it just set at 3 if you're not really looking to add a ton. And you can see that now I've got more friction involved, and I didn't really adjust it up that high. So what I would recommend is really just keeping the particular actor or the ground, one of them at kind of the default at 3, and then use one particular side of the equation. So I wouldn't add friction to my player. Let's say, for example, I would add friction to the object. That way I'm not trying to adjust all these calculations between the actors. As long as they're in a positive value, it's basically only one side of the friction that I'm going to have to adjust with, and it makes it easier instead of keeping track of all this other stuff. So let's just go ahead real quickly, and we'll just go ahead and take a look at bounciness, and I'll get rid of that, and I have my ground. And I'm going to go ahead and let's just go ahead and flip these rules. And I'm going to go ahead and make this down. And I'll change this to, actually, I don't need to change that one. So let me go ahead and turn this rule off. Since I have a down velocity, I only need an up velocity. So I'm going to do an up. And so when I'm doing an up velocity, I want more of a, I'm going to use you can use this behavior. We'll use the move behavior. But a lot of times you may want to use an accelerate behavior. But what we want to do is we want to make sure that our speed is at least double the acceleration. It's got to be positive over, because we've already got a force of 100 pulling down. So in order to break that gravity, we need to have a greater force moving in the opposite direction. So that opposite direction would be 90. So if I have it on this, now this is going to basically make my actor move up and down. So that's not really like how we would like it, but it's a basic example of how you make an actor, and you can tweak those accelerations to make them a little bit snappier. So let's go ahead and we'll just add a bounciness of 1 to our player actor, and we'll see what happens when we jump up and then we come down. And so you see we're getting a bounce now. And if we go down here, and the highest you can go on this is 2. And so you can see we're getting a lot of bounce now. But you can also move this value. A lot of times you're going to move this value, especially when you're dealing with higher accelerations values, which a lot of people usually are. You know, you're probably up higher. So let me go ahead and increase this, and then let's make this 450 for a jump. And let's just see what happens when we get into a more snappier. And so you can see your actor will start to bounce really high and actually kind of bounce too much off the scene. So what we want to do generally most of the time is let's go ahead with it's like a 0.3 bounciness, and we'll see what that gives us. You can actually work these most of the time. You're going to work bounciness in decimal places, and we can see that gives us a much smaller kind of a bounce. And we can go, let's go to 0.6, see what that kind of gives us for an effect. And you can see we're getting a little more of a bounciness here. And we could go all the way up to 1 on this. And you see we're getting a pretty nice bounce at once. And if you wanted a little more, you could go 1.1, all of that. One of the ways that I'll quickly show you how to control your bounciness as far as getting a nice snappy bounce, what we can do is we can come up into this motion tab and we can apply a max speed. And so let's say, you know, we're going up at a speed of 450, but we want to have the bounce maybe give us a little higher. So let's set just for now, let's set the max speed to 550, and we'll go ahead and let's go ahead and set that bounciness back up to 2, where we're getting that really high jump on that. And so what this is going to do is it's going to let us have like that, let that bounciness build up, but we're not going to get that. We're going to get a consistent bounce every time, as you can see, because basically we've capped off the peak of the velocity. Remember last time when I showed you that the actor eventually accelerated right off the screen. And so basically when you use the max speed cap, it's going to allow you to have that nice consistent bounciness every time, a more controlled bounciness, a more consistent bounciness to the same level in your game all the time, without having to reduce that snappy bounciness that we're getting right now. So a lot of times what we would do is we would go in and decrease the bounciness because we don't want our actor going up so high, but that's also going to reduce the height of our return on the jump. So by using a max speed value with a good, you know, high value on our bounciness, as you can see, let me just get my mouse kind of in the position where it peaks out, and we'll see we're going to get a very consistent bounce pretty much every time. It's going to go back to that same spot because it's rolling off the peak of the acceleration when it matches that. So this is the way using bounciness. The max speed is very handy when using the accelerate behavior to really get control of the environment that you're working on, and kind of stabilizing the physics system so that your actors, when they interact and collide and bounce, don't ever get out of control. You can keep it all harnessed in. And you can also, this value here, the max speed part, now you cannot change apply max speed at runtime. You already have to have it checked. But what you can do is you can put a high value in here to start if you don't want to have that high of a cap. And at runtime, you can modify this value. You can jog that value up and down depending on where you are in your game to change that max speed value during runtime. So that really allows you to gain more control over your physics in the Gamesalad engine. And so, as you can see, we've looked at density, friction, bounciness. These are not editable at runtime, so you have to establish these values here in your game. You can't edit those. You can't change fixed rotation. You can't change movable. You can't change the collision shape. You can adjust drag and angular drag. You can adjust angular velocity and max speed, but you cannot change these other ones at runtime. So you have to figure out and kind of build your physics world to what you want it. Now, one of the other things that I recommend that you do, like you see me doing here, and generally a lot of times while I'm building a game, I do a lot of prototyping. And so I'll go in and just grab some actors like this and start to build a simulation of what I want to happen in my game. And this really allows me to have a control environment and strictly focus on the particular variables that I want to address and adjust till I find what I'm looking for without having to go through. It's a time saver because without having to restart your levels and go through all the stuff, you can go ahead and build this little prototype. Now, you don't have to build it in a separate project. It's as simple as just having this blank scene in your game that you can go ahead and you can drag it right to the front. So if you want it to boot up when you go to preview, so you can just have this little blank scene, that you go in and do prototyping work on, and then you can go ahead and just drag it to the front of the line temporarily. And so every time you hit preview, that'll come up, and you can, and that way that allows you to do is work on actors, work on obstacles in an isolated environment where you don't have all these other game mechanics going on, and you can focus on kind of getting all your settings zoomed in, kind of focused in, and then you don't have to redo the code because you've already got it here. It's all contained in the same game, and you can drag it out into your customs and then drag them into another actor, those snippets and pieces of code. And that's generally how I like to work because it helps me just get focused on the things, and it's a real time saver without having to go through the repetition of going through all these different aspects until you get to that portion of your game to evaluate what you're trying to adjust. So this is Dave, the guru, and with part 2, and we'll be back with part 3 where we'll start looking at actors in a movable environment and how to different ways we can constrain and stop them and fix them and deal with some other issues in the physics engine. So I'll see you in the next video.